Hello, welcome to Baba's World. This tutorial is about AI and not just AI. This is all about AI. We are going to dive deep inside various concepts for building AI tools and systems. I'll explain theory behind everything. This is not an academic course, which is usually very esoteric and difficult to follow. This is not even a course provided by a service provider or some company whose intention is usually to promote their product. Here in this course, we'll learn concept using real life analogy so that you can really relate it. We'll go deep inside theory. We'll do practicals through coding and using tools. We'll review various research paper, but we'll go step by step. There will be 3 levels that I'll explain later, but this will be a course which will cover breadth and depth. We'll go very deep inside AI so that once you complete this course and whichever level you choose, you will be at top 1% who knows about AI.
Now, what is the meaning of artificial intelligence? We are now in Britannica website. Artificial intelligence, the ability of a digital computer or computer-controlled robot to perform tasks commonly associated with intelligent beings. The term is frequently applied to the project of a developing system endowed with intellectual processes characteristic of humans, such as the ability to reason, discover meaning, generalize, or learn from past experience. So if you refer here, these are the keywords: digital computer or computer controlled robots. So computer is in the heart of artificial intelligence. Whatever algorithms you are building, the data you are collecting, ultimately everything you are running through some sort of computation. Now, how artificial intelligence is built and what you are trying to achieve. So if you see here, it's talking about the ability to reason, discover meaning, generalize, and learn from past experience. So all these are human behavior, or in a way human intelligence aspect. And we are saying once machine, the computer, has that kind of intelligence, we're calling it artificial. So one side is human intelligence, and when we are artificially building using digital computer or computer controlled robot or some kind of algorithm, we're calling it artificial. Now let's look at another example at Wikipedia, and in Wikipedia we can see artificial intelligence in the broadest sense is the intelligence exhibited by machines, particularly computer system. Is a field and researcher in computer system science, develops and studies methods. So ultimately, again, here also we can see we are talking particularly about two things. One is about computer, the other thing is about intelligence. Now, human intelligence, there are many methods to identify intelligence. How we can say someone is intelligent. We have IQ measurement scales which test someone's ability on different aspects: reasoning, retention, recollection, all those aspects. Similarly, we'll see later, even for artificial intelligence, there are different measurement scales, there are different benchmarks based on which one can say or one can evaluate an algorithm how intelligent it is.
In this tutorial, we'll dive deep inside machine learning, deep learning, computer vision, natural language processing, generative AI. Not just these alone, we'll also learn about robotics, search algorithm, expert system, fuzzy logic, evolutionary computation, swarm intelligence, planning and scheduling, and many more. We'll cover how AI lifecycle works, starting from business requirement, different analytical approach, what are the data requirements, how data can be gathered and collected, how data need to be pre-processed, cleaned, what kind of models need to be used, We'll go through model selection process, model evaluation process, then we'll dive inside model deployment process. How to compare different model, how to fine tune the model. Once models are running in production, how to monitor them. Do you need to retrain the model? How to retire a model? How to replace a model? Are this model ultimately achieving the business goal? We'll cover everything, every aspect of artificial intelligence.
We'll also cover responsible AI, which is about fairness, accountability, transparency, and what is the impact on society. We'll talk about ethical AI. AI development should build with ethical principles in mind, like fairness and privacy. Explainable AI. AI models should be explainable to regulators or any government authority or even within the organization, how to understand if there are hundreds of variables which all are impacting the final decision or outcomes in that model. We'll also discuss about AI safety. It's paramount that whatever AI systems we are going to build, they should not harm humans or the environment. Algorithmic bias is another key aspect while building AI models. We need to take care any kind of bias that may be introduced due to this model deployment. This may be due to limitations in data, or data is collected which is not homogeneously distributed, or there may be various aspects. We'll dive deep into it and see what may be causing the bias and how to prevent it. Human AI interaction. This is about the design safe and effective ways for humans and AI to work together. We'll dive deep into all the known practices on how to build safe and effective interaction models between human and AI. Last but not least, we'll also cover societal impact of AI, mainly around job and governance. Artificial intelligence has many branches. One of the main branches is machine learning. Deep learning is very popular nowadays. Most of the AI innovation or changes that's happening around us are due to deep learning revolution. Again, deep learning is a subdomain of machine learning. Similarly, computer vision, natural language process, all these are part of deep learning, as well as some of the algorithms are built using machine learning, which are not really deep learning. We also see many of the computer vision, natural language processing algorithms were not built using machine learning or deep learning. But those were mostly before deep learning revolution that started around 2012. In recent time, generative AI, large language model, multimodal model, all these became very popular. And these are predominantly part of deep learning, and they're leveraging various aspects from computer vision, natural language processing. Other than these areas in machine learning and deep learning, we have also seen many other branches in artificial intelligence like fuzzy logic, search algorithm, expert system, planning and scheduling, evolutionary computation, swarm intelligence, and robotics. Now, you might have noticed there are a lot of overlap between these systems. Many of these models are built utilizing knowledge area from these subdomains. If you refer to many of the current tools or final product, they're not independently built on one sub-branch, but combination of many branches. I'm sure you have heard about AlphaGo from DeepMind, which predominantly used reinforcement learning, which is built on top of deep learning and traditional reinforcement learning. But it also used search algorithm Monte Carlo tree search. Similarly, robotics, where it has its own standards and own algorithms, but gradually we are seeing it is also leveraging many deep learning aspects like reinforcement learning. Some of these artificial intelligence branches are quite old and not used so much now, but still they have usage. If you refer to fuzzy logic, which is built on the concept of imprecise data or partial truth or vague data, we can see usage of it in our day-to-day life like rice cooker or washing machine or even in networking. Search algorithms are everywhere. If you have used any of ride-hailing service, they are using search algorithm. Self-driving cars are using search algorithm for pathfinding. Search algorithms are helping effectively find the optimal solution. Even expert system, which is a very old artificial intelligence branch, is still being used. Even during COVID-19 pandemic, expert system was used to decide healthcare. This is more like a decision making. It has usage in areas like diagnosis, detecting fraud, and even in areas like project management. So ultimately, even though this tutorial will be focusing more on machine learning, deep learning, but we'll also take a look at other areas of artificial intelligence like swarm intelligence, fuzzy logic, and so on and so to reinforce overall understanding of this field. As you are going to build any new tool or new solution, you should have all kind of knowledge, all kind of tools, and then you can make an informed decision which one to refer. That's the ultimate objective of this tutorial, to equip you with knowledge, information, and required tool so that you can take on any challenge in artificial intelligence. Now you may be thinking, what's in it for me in this course? I think if I give an analogy with car and people who are involved with car, it may be easy to understand. So you can think car is like a metaphor for artificial intelligence, and there are different kind of people who will be using car. There are people who will be using car as passenger. Right? You don't really need to know too much about car. In general, at very high level, you will know about the car, and it's good if you have some knowledge. If you want to buy a car, you can utilize your knowledge. The second category of people would be those who are driving the car. So as a car driver, you need to know a little bit more about the car, and preferably you will know how to drive the steering, how to use gear, and a little bit about car, or at least car navigation system, or the panel, or different switch, indicator. All these things you need to know to drive the car. Third category of people would be those who are building the car. They may be designing the car. They may be someone who is expert in designing the engine. If there is a problem, they can fix it, or if there is a new car to be designed, these are the people who will get involved. Now, this course is also structured exactly like this. If car is like an artificial intelligence system, then these three personas are the three levels of learning that you will have in this course. Car passenger, I call them AI enthusiast. Car driver is AI practitioner, and someone who is designing or able to maintain the car is AI wizard.
In this tutorial, we'll cover three levels. So as I gave the analogy with car, there will be AI enthusiasts who are like passenger. These are the individuals with no prior AI knowledge, but they are curious to learn about AI. What is the potential of AI? They want to know about it. Second level, I call them AI practitioners. They're like driver of cars. These are the professionals who want to leverage AI tools to solve problems in their respective field. Third level is about developers and researchers who are aiming to design and build AI models and algorithms. These are the people who will pioneer in this field. I call them AI wizard, and we'll have separate playlist so you can refer to the naming convention for the videos to find exactly which category of videos you are interested to. There will be certain videos you will see that same content have three different level, and there will be three different videos. Like for AI enthusiasts, it will be more on the basic concept. Practitioner, it will go more about how to use some of the libraries or models or tools, and while for wizard, it will talk how the models are working underneath, what are the mathematical background or statistical background behind it. If there is a research paper associated with it, I'll go through, and also will dive deep inside the coding, even going inside some of the standard libraries or the implementation of the code in those libraries.
that's all for this video. What are we waiting for? Let's get started. Thank you and see you in